starts to multiple finishes. Unlike probably a railway or a road, which might go from one location to the other. So this poses an additional challenge for what we were planning, what we were trying to address. And with this, we took our objective as to being basically to design a web-based GIS system to support this kind of projects and actually implement one and evaluate the prototype and learn lessons from it and take it further to a more robust implementation at a later stage. Now, this is the basic methodology we used. We needed a lot of input from the site, whether it was the project execution team or the project monitoring team, as well as a management team, which makes the kind of decisions on the project level. So we had three basically inputs from three teams of people, which was the management team, and then the monitoring team, which actually uses this tool. The execution team gives the inputs. So based on their inputs, a platform was designed and developed. Then a field study was done, and then the findings were presented. And this is what we will go through the sequence. So if I take the management team, if I look at the slide, there would be two parts to each team. So we have the management team here, the monitoring team, and the execution team. The management team gives inputs to the monitoring team for what they would be looking for as output. The monitoring team has a double or a triple role, I would say. In addition to actually doing monitoring the traditional way, they are instrumental in the development of this tool. So in addition to having certain program capabilities, the monitoring team actually does the tool development. They are also the interface between the execution team and the management team. So the monitoring team not only does the development of the tool, but all the data that comes from the execution team when the project is progressing, goes through the monitoring team, which produces the reports for the management team. And once reports are produced, whatever decisions need to be taken, whether it's ordering materials, whether it's changing priority on what needs to be done, all of this is then communicated back to the execution team through the project monitoring team. So to be able to translate this into a system architecture, especially with a GIS or a spatial database, these are the basic components which we had. We had basically a form builder which was required to be able to get the data in. We needed a spatial database, a web server, which would then translate this to a client and to a browser, which would make it more spatial and graphical the way a user would like to see it, whether it was spatial information or querying for non-spatial information. Now, we translated this system architecture concept using specific tools that are available. This is a set of tools which we chose. You can see the Open Data Kit, which we choose for the forms, the Postgres SQL for the database, PostGIS for the geographic information system, and the Node.js and Leaflet interface to serve the maps to the browser. So this is the set we used. It's open source. It was easily accessible, and we were able to then develop platforms over this. If you're interested in more details on this, Varun has loaded this on GitHub and you can access this. But this was basically the architecture which we went with. And to put this in a little more of a flow form, we basically had the form creation here, and then with ODK, whether there's a creation, the filling of the form, data storage went to Google Sheets for now, translated into a database with GIS, and then back into a browser to be able to present the data, whether it was the numeric data or the visual representation that was required. Now, I will just go through this, some of these elements. I will not spend much time on it. I'm just going to kind of go through the slides to give a feel of what this involved. So here we have the data forms, with the Open Data Kit environment, which was defining the forms. Here we can enter data into the forms on a mobile platform. So you can see kind of the screenshots from a mobile platform where you can actually get the data entry done, get it into a Google spreadsheet at this stage for kind of storing the initial data, take it into a relational design database where it goes into the spatial database also, where we take Postgres SQL and PostGIS and combine it together to have the overall spatial database function that is done. So this is the basic structure of what was architected and developed. And when we move this into where the project decision support comes, we found that there are several applications that it can be used for from an information for decision-making perspective. Whether it was your material management decisions, whether it was your project scope decisions, the schedules on your projects, the project budget, the manpower, machinery, all of these elements could potentially be modeled in this spatial database, and the results that came out would be far more effective, far more visual, far more location specific than if you use a normal project monitoring system. So this gives you a little bit of a feel of what the interface is. Basically, you have a spatial side, you have the queries which you can generate from the text side. And these are the typical queries we at least initially thought we could generate. So we have the materials, the schedules, on all of the different dimensions we look from the management perspective. We had spatial and non-spatial queries. We have the queries that can be at a routing level or at the project level. When we say routing level, it means basically the query that you would ask about a particular route, the progress of a particular route, or the attributes of a particular route. Whereas at the project level would be the combination of all these routes. So let me just illustrate some of these queries. So here is an example of a route level query where I could click on a particular route and then find actually what is the actual scope of the route and how much work has actually been completed. We could get the name of the route, the cable laying status, when was it last updated, what is the start point, end point. These are some of the attributes, but it could also involve, a lot more attributes associated with the route. So here is a project level query, which asks, which are the routes that are yet to start? So I want to know which are the routes that are still not even in the first phase of construction. So this would give me all the routes in a visual way so that I could then kind of communicate with my team and discuss how to progress on this for the next, or how to take control actions on this. Here is another query, which is a route level from a material perspective. So cable drums are a very important part of the resource that is required for making progress. And you need the right drum, the right kind of cable there. So based on what kind of cable is available, or cable that has been allotted, I would be able to do a query and find out where is the cable, how much length of cable is available for that route. Do I need to order more cables for that particular route, or is the drum sitting idle there, and can I move it to another location which actually is stopped because there is a lack of material there. So all of these kind of more complex queries can also be based on this database. And here is a very high level query on looking at the progress of the project from all the routes that are kind of aggregated into finding the length and calculating the percentage progress, which is described a little more detail in the paper, but the percentage progress is not just based on overall completion of the whole all the activities, but based on even partial activity completion on a project. Some kind of a weighted average or some kind of a level of effort method can be used to kind percentage progress here. But this gives a snapshot of at what levels the queries can be asked. Now, in addition, we found that when we look at linear projects, it's not just about the cable laying type which we had, which actually typically follows a road perimeter or along a road. So which means the linear projects was in several segments like this. You could also have linear projects which are in straight lines. These could be some underground element that was decided, which was buried, it was done from a trenchless point of view, or it could be something like a transmission line, which could be across a shortest path approach. So these are also options that can be modeled with this, again, showing the flexibility of the system. Now, coming to summarize, so one thing which we learned overall is that using a geographic information system or the spatial database system definitely has, when we implemented this and kind of showed it to the teams, there's definitely a lot of communication ability that it possesses. And so it's definitely relevant for linear project management. And the spatial setup we used was, you can see it's limited geographic space, but several segments. If you took it to a larger linear, project space like a railway or a road, there would be definitely advantage in using such a system again. One of the actual pluses on this, which we've discovered, is the technology, access to technology. The open source technology we used was absolutely, not only just accessible, but implementable with very, very, little level of effort. Okay, so you can see the amount of customization, the amount of user friendliness and implementation was something that was a real plus. And I'll talk a bit more about this in my next slide. And the overall architecture we had designed seemed appropriate for this. I'm sure we can go into a more sophisticated architecture, but for the simple prototype platform we developed, it was more than adequate. Now, going into our findings from here, one of the key findings is this issue of rapid prototyping. I've been on several projects where a software team would come in and look at the requirements, go develop some kind of prototype, come back, and by the time they come back, the users would have changed the requirements or say, oh no, this is not what we talked about, we wanted something else. The kind of platforms we use today, whether with the open source platforms, not only are they open source, but the user friendliness of being able to do a rapid prototype is very, very, it's much better than what, as technology progresses. So it is not, you don't require a specialist software team to do this. You just need a person embedded with the monitoring team. And we found that because there's quick cycling of the prototypes, we are able to converge on user requirements much faster. So I think this is a big positive for construction, because a lot of times our users are not able to necessarily articulate what they would require in one go. So having, being able to do kind of cycling on this very easily is kind of a very, very important part. And then the fact that the platform is robust, documentation is there, implementation ease is there, I think is a big positive. And fact that it's open source, of course, is even better. Now, in the field study, we found, I think I've mentioned this can be applied to single or multiple distributed workfaces, which we think is the flexibility of application. The graphical and spatial reports definitely improved communication and interpretation. The minute you see something in a spatial layout, decision-making is better. And definitely the other aspect, because a lot of this, so a lot of times we can develop tools, but the implementation team or the project monitoring team does not adopt it into the process because the tool is alien to them. So here the tool is developed along with the process monitoring team. So it's much, the project monitoring team, so it's much easier for them to adapt it into their process. So when we talk about the dimensions of what people, process, technology, a lot of times technology is developed without process in mind. So people don't tend to use it. So here we have an integration of the three because the platform is relatively low overhead to use. So we are able to adopt it into the process. Looking for further work, where we extend this. So definitely a lot of the decision support functions which we have developed are basic and they can be extended much more. And we see a lot of scope for expanding this into a full-fledged decision support system. There can be a lot more automation opportunities as we go forward, including some of the IoT opportunities in being able to recognize what's being done, automatically. And definitely as we go forward, something like this needs to be integrated into a ERP system because that's where a company or a project would store all of its data and be able to do more higher level decision making. So overall, we had a very positive experience in the tools we used, as well as the architecture we developed seems to be something that is viable for scaling up further. So with that, thank you very much. And I'm happy to take any questions.
Thank you, Dr. Koshy. Thanks for your presentation. And thanks for your time. Again, if anyone has a question, please share it with me and I'll share it with Dr. Koshy. We'll give it for a few minutes for any questions. Until then, Doctor, if I may ask you a question about how we can use GIS using this platform. Can we use it for machine learning, for predictive data learning?
Yeah, absolutely. I mean, in this platform right now, I mean, we have not designed that, but you could use it. I mean, like I said, if you wanted to not actually have someone manually enter the data, you wanted to some kind of a drone go on a site and then recognize what's being done. It could be used for that. It could be extended to adapt that in. Right now, it's manual data entry, meaning the person at site has to enter where the project is or what the status of construction is. But this would be automated as we go further.
But because currently in Ministry of Infrastructure in UAE, we've been through lots of research using how to use GIS to get data of our current projects and how we can transform these data using a platform for predictive requirements and predictive analysis for future development. So I think this platform can help us in this such tools, but it's always been a challenge about collecting the data, as you mentioned.
Absolutely, absolutely. So there are two parts to this. A lot of times collecting data is when you give a form to someone who's not familiar with the form, they always have, and you then have to train them and all of that. So one of the advantages we found here is the form was developed along with the people in the field. So it becomes easier for them to relate to what is there. So that is actually the bar of being able to develop such platforms is dropping. It is almost like, I mean, if you get onto Google Forms today, you can do whatever is required and you don't need to be a programmer to do it. So we're getting to that stage, but obviously the fundamentals of your GIS, the fundamentals of your spatial database management has to be, you need a team to do that, or you need an embedded person to do that.
Perfect. And do you think that this, as a GIS platform, does it matter about the stage of the project? Would it matter in the platform? Like, for example, it's a project that's in the planning stage, design stage, or in the infrastructure stage. Yeah. Does it matter to affect the platform?
Yeah. So this would be more in the physical construction stage where you're monitoring. So if you want to monitor the design and the initial planning and design stage, it would be, I mean, you definitely use the GIS because your initial routing, all of those matter. Are these the optimal routes? Can I find a different route for what I'm planning? All of those definitely matter, or even kind of optimizing the trenching. You could definitely use the GIS and all those phases. But we have not addressed that as of now, but that could be, what do you say, pre-processing modules that could be added to this, definitely, because the geographic, it's all based on spatial and geographic data.
Yes. Thank you very much, Dr. Koshy. I don't think I have a question here from Kareem. Is this system linked with the schedule for automatic updates?
Right. So right now it's not linked, but it can easily be linked. It could easily.
Does it require any special platform for automatic updates?
No. So you will have to now link it to your Primavera or your whichever platform you're using. So wherever that kind of data bridge is required, you will have to link it. So just as we have 4D for BIM, you can have a 4D for the GIS also.
Perfect. If anyone has any extra question, I hope Kareem this answers this question. Thank you very much, Dr. Koshy, for your time. Do you have any final note before we go to the next paper?
No, but if people have